Hey everybody, I'm Chili. Welcome back to Intermediate C++ Tutorial 9. This is going to be the last tutorial focused on the console, so I figured we'd do a game in console mode to wrap up this arc of the series. So we're going to make a word guessing game with a little bit of a twist that makes it highly deductive and surprisingly fun to play. This is going to give us a chance to practice the string, stream, vector stuff that we've just now started to use. So let me give you the basics here. You're gonna have a 5-letter word that you're trying to guess, and so you have to enter 5-letter words, and it'll tell you whether you've guessed correctly or not. But I mean, there are a lot of 5-letter words that would be pretty hard to do, so you get hints, and the hints come in the form of points. So you get a score for every word that you enter. For example, let's take the word beams. So our target word is pubes. We don't know that when we're guessing though. The word beams. So you get 1 point for every letter that matches, and you get 2 points if the letter matches and is in the correct place. So we have exactly 1 letter that matches and is in the correct place. So that's 2 points. Now we have another match here. It's not in the right place, but it's a match. So that's 1 point. So this would be a 3-point guess. Now, look at this one here. You've got 5 E's. So you might say, well, here is 2 points, and then these are all in the wrong place. So together, this would be 2, 3, 4, 5, 6 points. But you can't match 2 letters to the same letter in the target word. That doesn't count. And also, this would never actually be scored because it's not a real word. You can only guess real words that are in the dictionary. That's part of the game. So the more words you know, the more ability you have to guess and to reason and to narrow down what letters are where. It's part of the game. So let's look at one more just to check it out. So pukes, right? So P, U, E, S are all match up in the correct place. So that's 8 points. And then you got K, that doesn't match, so this would be an 8-point guess. You get the idea. Let's make the motherfucking game. So I'm gonna create a new project here, call it Word, and I'm gonna make a new Git repository. There we go. We'll go Solutions, Source Files, Add, and I'll go New Item. You couldn't see that, but trust me, I did it. And we'll just call this one, I don't know, call it main.cpp. We're going to add our int main in here, and before we get started, I think we probably are going to need some kind of list of words, because remember, you can only guess real words that are in the dictionary, and we also want, dictionary words to select the target word. So we need some kind of database of words, 5-letter words. So, you run a basic Google search, list of all 5-letter words, and I mean, this is maybe fine, but I want something simple. Like, this ain't gonna work for us, right? I need something simple, like a text file that I can just load. So we'll just refine our search, text, and we take a look at the first one. This looks like exactly what we want. It's a nice text file. So I'll right click, save as sgbwords.txt. We'll put that shit on the desktop. Then what we can do is we'll go, resource files. Okay, we're going to right click here. We'll put SGB words into here. We'll put that in resource files. And Bob is your mother's brother. I don't know how many words we got here. We got like 5,700 words. That's a lot of words. It's a lot of words to work with. All right, so let's load. We want to load these words into a vector. So we're gonna include vector, and we're gonna include fstream. So std vector. There's a bunch of sexy ways we can do this, but we're gonna keep it simple. We need strings, so let's go include. I can never type include correctly the first time. It just doesn't work for me. Vector std string, and we'll call this one words. 5 words. That's a weird name, but you get the idea. Now we want to open up the file. So the file is going to be, let me think here, std if stream, 5-word file, and this is going to be sgb words.txt. Lovely. All right, now we want to load those into the vector. So what we're going to do is we're going to go for std string line as long as std get line 5-word file line. So we keep loading lines from the file into our line string until we reach the end of the file. Now if line dot empty, so if we just get a blank line, continue. Otherwise, what we want to do is go 5-words dot push back line. So we'll push that line back into our vector, and this is going to load all of our strings into our vector. Now, what we can do just to make sure that this worked is we're going to go IOStream. And just go print out all those words. So do that like that, and finally we're gonna, just wait for the user to press the enter key. One final little optimization, I wouldn't call it optimization here, but a little streamlining, I guess, is we will put this in its own little scope, and that means that we'll close this file when we're done in here. It's not a bad practice to close your files when you're done with them. So we'll load all the strings, all the words from the file, and then we'll print them all out to the console. Should take a little while because it's a lot of fucking words. So there you go, we're printing out lots of words, and we're still printing out words, and we're done. So press enter. Beautiful. Okay, so it looks like the loading is working fine as intended. Next thing we want to do is basically we want to select a random word from within there. That's going to be the word to guess. So delete this printing code. We've got to include random now. Random. And let's go std, and we'll just do mt, whatever, it doesn't matter. I don't really care what engine we use. RNG. We'll seed it with random device, and we'll create that, and we will call its generate function. So we create the RNG, and we need a distribution. So std uniform int distribution, and we're gonna have a distribution from 0 to the size of our vector -1. So this will generate indexes of our vector. We can use that to select words that will be the target. Next thing we go constant std string target is equal to, and let's go 5 words at dist RNG. So there we go. I'm going to use our random number generator distribution to select a word, store it in the target. Next thing we're going to do is we're going to prompt the user to guess a word. We're going to go std string guess, and we're going to go std get line, std cin, and guess. So we're going to get a line from cin, store it in our string guess. Now, we've got to make sure that this guess is legit. First off, does it have 5 characters? So we check if size is not equal to 5, and if it is not equal to 5, then we're going to tell the user to go fuck themselves. Now the guessing is going to happen in a loop, right, until the user actually gets the correct one. So let's make it a loop. We'll go while true, and we'll do this. Now, if they fuck up, we'll just continue. Go back to the start. Go back to here. Continue. There's a U in there somewhere. So first check passed. Let's do the second check. Does the word actually exist in the goddamn vector? That's a good question, right? So let's make a function bool vector contains word. So it's going to take a constant reference to a vector of std strings, and it's going to take a constant reference to a word to search for. Now there are good things to do this in the standard library, but we're not going to use them yet because we need to learn about iterators first. So we're going to do it. We're going to do it manually. So we're going to search for a word, and the way we're going to do that is, for each constant auto ampersand word w in vec. If w is equal to word, return true. Otherwise, return false if you go through the whole vector and you still haven't found it. So, vector contains word. There, we got our nice function there. So, second test. If not vector contains word, and the vector is going to be 5 words, and the word is going to be our guess. So the vector does not contain that, then we've got a problem. Let's yell at the user. So we'll repeat the user's guess, and then we'll tell them that, they fucked up. That is not even a fucking... now you're just... Don't be weird about it. Just talk normal, bro. Alright, so probably should put an endl on here as well. So std endl. And so that's the second test. So if it is the right length and if it is in the thing, then we've got to grade that motherfucker. We've got to figure out how many points it gets. So let's create a function to score the matches between words, shall we? So it's going to return an int, which is the score, and we're going to call it, I don't know, score match. That's not how you spell that. All right, so we're going to take const std string reference to word 1 and a reference to word 2. Now, the way we're going to score it, we're going to break it down into 2 parts. First, we're going to score how many letters match. Then we're going to score how many letters are in the correct position. Now, to score the letter matches, we're going to break it down into buckets. So we're going to have buckets from A to Z, and we're going to count how many A's, how many B's, how many C's, and then we're going to compare the buckets from word 1 to the buckets from word 2, and we're going to add them all together. So we're going to go std vector int, and this one's going to be called fill buckets, and it is going to take a reference to a word, and it is going to fill the buckets of this vector, 26 of them, with the counts of each of those letters. So how does that work? Well, we'll go std vector int buckets, and we're going to create 26 members, and we're going to initialize them all initially to 0. Then what we do is for each car C in word, buckets at C minus A. So this will give us an index based on the letter. So A, if the character in the word is an A minus A is going to be 0, right? So it's going to be index 0. B is going to be index 1. C is going to be index 2, so on and so forth. We might want to put an assertion in here to make sure that there are no letters outside of from A to Z, but I'm not going to worry about it right now. This is just a quick and simple little thing we're doing here. So that plus plus, we'll just increment that one, and that'll fill the buckets, and then we'll just return bucket buckets, and that'll return this vector. So fill buckets. Now we can do constant auto buckets1 is equal to fill buckets word1, and we can do buckets2 is equal to fill buckets word2. Now what we want to do is we want to count how many matches there are. So imagine word 1 has, 3 A's and word 2 has 1 A. The number of A's are going to be, the matches are going to be 1, right? Because you can only match 1 A with one of the A's in the other word. So we want to take the minimum of the 2 buckets for every bucket in both words. So what we do is we go for int I is equal to 0 as long as I is less than 26, I++. And we're going to do int score is equal to 0. So we're going to loop through all the characters in the buckets, and then we're going to go score plus and equals std minimum. I don't think we have minimum yet. Minimum is declared in algorithm. So algorithm. And this will allow us to get std min. And we're going to go from buckets1 at I and buckets2 at I. So we'll add that to the score. So this is our scoring for the matching of letters. Now we want to score to see if we have letters in the correct position. So what we do is we go again for int I is equal to 0 as long as I is less than 5, I++. And for every place where word 1 at I is equal to word 2 at I, if then score plus plus. So we get an extra point for every letter that is also in the correct place. And then return score. So there you go. There's your score matching function. So we vetted the word. Now let's tell the user their score. So first off, constant int score is equal to score match dumb name guess target. If score is equal to 10, that means we've won. So give the user a nice message, and then we break out of the loop. Otherwise, so we tell the user they didn't do it, but we give them a score, and that'll allow them to adjust their guess. Now, finally, we need to do our ignoring bullshit in here, like this, and yeah, let's give it a shot. I don't know if this is gonna work or not, but it's worth a try, right? At least it compiled. That's worth something. Guess a 5-letter word. Pubes. Now that ain't. I'll give you 2 points for effort though. Retard. Omega is also 2 points. Tools is 2 points. Oh, porno is 3 points. Put the wrong letter count in there and you get a nasty message. You put a non-word in there and you get another nasty message. Now there's one problem here that we probably want to address, and that is, let's say I write pubes, but I put a capital in there. It's going to tell me that ain't a word. And the reason why is because capital P is different than small p. So what we want to do is we want to normalize the input from the user so that it is easily compared to the words in our text file. Words in the text file are all lowercase. The user takes the input. Let's make it all lowercase. Now there's a nice function for that. I'll just tell you it right now. So we can go for each, auto C in guess. And actually we want to do reference because we want to modify that shit. And what we're going to do is C is equal to std to to lower. Lower. All right, I can't remember the name of it. Well, give me a second here. All right, std to lower. Where is it? Where's my head at? CC type. All right, so let's try to include CC type, and we'll see if that gets us any kind of mojo. CC type, and where is it? Here it is. So std to lower, we got it, and we're gonna put in a C there. So this will convert all to lowercase. If we run it. Now if we type in, let's move this so that you guys can see it. Type in pubes, the capital P. That ain't it to give you 2 points. So now that's working. All right, so peels gives us 1 point. Now here's a little trick we can do. We can try pools and see if E changes it. That's 0 points. So right now we know that the word has 1 E, and we know that it has 0 O's, 0 P's, L's, or S's. So no P, O, L, or S, and it has at least 1 E. So let's try tools. 0 points, so it has no T. Let's try trips. 1. So it's either R-I or P. Let's try traps. 2 points. That could mean a bunch of different things, but it means at least the word should have an A in it. So it has 1 E, it has 1 A. Eater, that's 6 points. We're actually like really close. Eaten, 4 points. So we know that the last letter is probably an R. Tapir is 4 points, so we know that the ER is important. So I think it's AER, and just the first letter and the third letter are the ones we need to figure out. All right, water gave us 8 points, so we know that T isn't the one, so it's got to be W. So WAER. So what else can be in here? Well, we got whapper. That's not a word. Wagger? Wager. Could be wager. That's not wager though. Could be wainer. That's not a word. Could be whacker. That was a word. Waker was a word, but it was not the word we're looking for. Could be Could be waxer. It's waxer. Okay. Well, I mean, it's not really a very common word. It's not a fuck you game. So that's it, really. It's just a fun little game that we can makes use of strings and vectors and some of the stuff that we've been learning in intermediate, we've been building up to. And it's a fun game. It requires a lot of deductive reasoning plus a good vocabulary. So I enjoy playing. I made a bot for this game on the Discord and I put it up there, and people enjoyed it. Now for the homework, we're going to address a little problem that this game has. And we can see the problem if we look at this text file. So the words in here, if we go to the bottom especially, we'll see that there are a lot of weird ass words in here. Shit like Osier, Robble, Biffy. Ain't nobody gonna be guessing these words. Come on. So what we want to do is we want to fix this, maybe get rid of the bullshit words out of this game. And the way we're gonna do it, I'm going to give you a link to this file here. It's on GitHub. It's a text file, and it's a list of the 20,000 most common words in the English language as ranked by, Google bullshit indexing, I guess. And this is in order of frequency. So use this data to maybe make the list of words that the game selects as the hidden word a little less bullshitty. And that's all I'm going to say about that, because I want you to figure out the details of how you're going to use that second text file to fix the problem. And that's it for this tutorial, and it marks the end of the console arc of our journey here. So starting from the next tutorial, we're going to be going back into the Chili framework, back into graphical programming, and we're going to finally be doing the thing that you guys have been wanting, which is we're going to load sprites from a file directly into memory and draw them on the screen instead of having those massive put pixel functions. It's going to be a good time. We're going to apply all the things we've learned about files, about pointers, about memory management, and we're going to get shit done. Until then, thanks for watching. I hope you enjoyed the video. If you did, please click the like button. It helps me a lot. And I will see you soon with some more C++.